Hello, dear students. Myself, Rupali Chaure, and I am assistant professor in SIRT College, Bhopal. So today we are going to discuss a very important topic of data analytics subjects, which is in fifth semester of RGPV curriculum. So as we have discussed about what is Hdfs and what are the main components like NameNode, DataNode, and secondary NameNode in our last video. So in this video, we are going to learn about what is the Hdfs write mechanism. Okay, so let's start the topic. So we will discuss today Hdfs write mechanism. So now let us understand what happens behind the scene when you are writing a file into the Hdfs. And when you want to write a file across your Hdfs or your Hadoop cluster, you have to go through main 3 steps. And the first step is that you should go through the pipeline setup and understand how to set up a pipeline with an example. So let us say that I have got a text file and maybe this is called example.txt or anything hello world.txt, and I have divided it into the 2 data blocks, which is a block A and block B. So let us talk in terms of block A first. Here it is shown in the diagram, block A, and I have divided my input file, text file, into 2 blocks, block A and block B. So first we will learn how block A will be written in the Hdfs. See how to write a block across my data nodes in my Hdfs. So here is the client, and the client at first requests the name node telling that I have got a block that I need to copy. So the name node says, okay, I will give you the IP address of 3 data nodes. You can copy your file in this 3 data nodes, and you know that you have to copy your block 3 times, because apparently we have already discussed about the replication factor. So the replication factor for this particular Hdfs system is 3. So the replication is 3, and the name node here gives the IP addresses of 3 data nodes: the data node 1, data node number 1, data node number 4, and data node number 6, as shown in the slide here. And now the client node has got the IP address of 3 data nodes where block A will be copied. So at first what it does, it goes and checks 2 data node 1, and as they don't want that, hey, I want to copy a block on your data node. So are you ready? It asks to data node number 1 first. So if data node number 1 is ready, so it answers that yes, I am ready, but you go and ask to data node number 4 and 6 also if they are ready, and the data node says 4 and 6 says that yes, we are ready. So then I will just go and ask to data node number 6 and 4 simultaneously. So now data node number 1 goes to data number 4, and data node number 4 goes to data node number 6. And as after this chain is completed, so of copying block, that is data node number 4 is ready, data node number 6 is ready. So it's okay that just go ahead and have data node number 6 and it is also ready. So this is how the whole pipeline is set up, that first block A will be copied to data node number 1, then data node number 4, and then data node number 6. Now let us say that in situations there are no data nodes available, that whatever IP address the name node gave, maybe those are not functioning or those data nodes are not working. So in that case, when the client node does not receive any confirmation, he goes back to the main data node and that says, hey, whatever IP addresses you have given, those data nodes are not working. So would you give me another IP addresses? And then the name node goes on and checks that which data nodes are available during that time and give the IP addresses to the client node again. So now your pipeline is ready. So in this way, the numbering here shows how the pipeline is set up by write request of block A from client node to name node through this number 1 point. Now name node provides IP addresses of 3 data nodes by this process number 2. Now client node goes to the data node number 1, goes to the core switch to reach up to the data node number 1 in the third step. Then from the core switch in fourth step, the client node reaches to the data node number 1. Now, if data node number 1 is ready, then this read request again goes to the data node number 4 from data node number 1 to 4 through core switch. Then if data node number 4 is ready, then this write request goes to the data node number 6 from data node number 4. So like this pipeline is set up for writing a particular block in this Hadoop structure. Okay, so now let us understand how the next process goes on. Now our pipeline is set up, and first it will be copied on the data node number 1. The block A will be copied on the data node number 1. Then they tune up and goes to the data node number 4 and then to data node number 6. So this is our pipeline, and now it comes the second step where the actual writing takes place. So now since all the data nodes are ready to copy the blocks, and client will contact data node number 1, and first the data node number 1 will copy block number A. So the client will give the responsibility of data node number 1 of responsibility to data node number 1 in order to copy the rest of the blocks to data node number 4 and data node number 6. And now the data node number 1 will contact to data node number 4, not the client machine. And data node number 1 will tell the data node number 4 that the copy of block A is available on the network. So you just write it on your storage and ask data node number 4 to send this data block A to data node number 6. So data node number 4 will then copy this block A and then pass the message on to the data node number 6. Similarly, the data node number 6 will also copy the block A, and now we have got the 3 copies ready, available, all time available on the 3 data nodes, data node number 1, 4 and 6, just as we require. So this is how the writing takes place. After that, the next step is a series of acknowledgements. So this is the write mechanism, writing of the process of writing a single block onto the 3 data nodes because our replication factor is 3. Now, after writing a single block, all these 3 data nodes will send the acknowledgement message. And we have a pipeline and we have written our blocks onto the data nodes that we wanted to acknowledge, and the acknowledgement will take place in the reverse order as the writing. So at first, the data node number 6 will give the acknowledgement to data node number 4, and I have copied and says that I have copied block A successfully, and then they did before we received that acknowledgement and pass it to the data node number 1, and data node number 1 also says the same acknowledgement message that I have copied the block number A onto myself, and so on. So this message, acknowledgement message will be passed to data node number from data node number 6 to 4 to 1, and the data node number 1 will give an acknowledgement finally to the client node that all the 3 blocks have been copied successfully, and after that the client will send a message to the name node that the writing has been successfully completed and all the blocks have been copied to the data nodes assigned by the name node. That is data node number 1, 4, and 6. So the name node will receive that message and update its metadata. As we discussed earlier, that name node stores the metadata, which is the data about the data. So all the details about the data stored on the data nodes is there in the name node. Hence, the name node updates the metadata about where all the blocks are copied in which data node. So this is how the write mechanism takes place. First a pipeline setup, then the actual writing, and then you get the acknowledgement. Now, this was the writing mechanism of a single block. But for multiple block writing, we have a parallel mechanism. So we just discussed only about a single block. As I told you that my file example.txt or helloworld.txt, it was divided into 2 blocks, block number A and block number B. So the write mechanism for block B will be just similar. Only when the client node will request a copy block B, he might get an IP address of the different data nodes. For example, block B is copied to data node number 3, 7, and 9, and block number A was copied to 1, 4, and 6. Now, let me tell you that the writing process of block A and block B will happen at the same time. This is the most important thing for this writing mechanism of Hadoop architecture, HDFS, that all the blocks are written in parallel fashion so that we will save our time and speed up the writing process. Now, obviously, I've told you that the writing mechanism, it takes place in 3 steps. So the actual writing will happen sequentially. That means it will first get copied to the first data node, then second, and then third. But the multiple blocks will be copied at the same time. So this is how the writing mechanism takes place. So the writing of block A and block B are taking place at the same time. And so 1A and 1B step is taking place at the same time. 2A and 2B steps, which are shown here in the figure, are taking place at the same time. So when the client is copying the different blocks on 2 different data nodes, 1A and 1B, 1A and 1B are taking place at the same time. Here 2A at the left side and 2B at the right side are taking at the same time. And when the first block that block is getting copied on the data node 1, and when block B is getting copied at the data node number 7. These processes are performed simultaneously. Similarly, the other steps are also taking place at the same time. As many as blocks your file contains, all the blocks will be copied at the same time. Hence, the actual writing mechanism means replication process is sequential, but multiple blocks are written in parallel fashion. So this is how the writing mechanism takes place. So now we will see what is a story behind reading a file in our next video. So till then, see you. Bye. Thank you.